this is Dominik, I'm Michael, and today we want to talk a little bit about eBay's journey over the last 3-4 years in the area of test automation. What did we learn? What did we learn oftentimes in a very painful way? So that's what we want to share today. This is not a prescription or a recipe how to do things. This is just, maybe a few pointers to people who are working in test automation at all levels in the organization. So basically engineers, test managers, or even department managers. I think there is a little bit for everybody in there to take home and to hopefully apply that in your jobs, in your companies. But before I start, I like to ask this question every time I speak. Who does not have an eBay account in this room? Okay. So there is room for improvement. Good. Maybe just a few facts before we dive into the 10 lessons learned. Just a few facts about eBay. So eBay is a relatively new company, founded in 1995. We're based in San Jose in California, right in the middle of the Silicon Valley with all the other Silicon Valley companies. And we've got about 28,000 employees. And there's a lot of other companies part of the eBay family, right? So it's not the company that I work for is the eBay down there, so the eBay marketplaces company where you buy and sell things. But then there's, of course, also PayPal, mobile.de in Germany, for example. In Turkey, we have something, and many, many more. So that's the eBay family. Now, a few facts about the platform. When I joined eBay, I thought, okay, big deal. It's a website where you buy and sell stuff. In fact, there's a lot more behind that. So if you look at this, we have roughly 100 million active users today in eBay marketplaces. The transaction volume is $68 billion per year, which translates down to about $2,000 every single second. And interestingly, about $1,000 of that is transacted outside of the US. So that's what falls into eBay International, and that's the place that we work for. A few data facts. So you can look this up on the internet. This is public information. So we have about 9 petabytes of data in our Hadoop and Teradata clusters. We get 2 billion page views or hits every single day on our servers. And we have about 75 billion database calls every single day. Yeah. So that's a lot of stuff going on. Talking a bit about mobile. Mobile is a very hot topic also for eBay. And I'm assuming in most companies, even just looking at the exhibition out there, there's a lot of, stuff going on in the mobile field, a lot of providers who have found test solutions or maybe even test automation solutions. For us, same thing, very important field, huge growth. So we have about 70 million downloads of our eBay Inc. apps. So so that's not just eBay marketplaces, that also includes PayPal and all the other apps. And about $5 billion last year were transacted on mobile devices, which is roughly 8%. So 5 billion out of the 68, I think that's 8%, somewhere around there. And massively growing. So looking very bright in the mobile field. Of course, from a testing perspective, huge challenge because you have 1 million devices out there and no real solutions to test that properly. And we have about 1 million items listed using mobile apps every single day. Every single week. Yeah. Good. So this is just a little bit of background on what eBay is. So now, who are we? As Hervé already introduced us. So I'm looking after this group called Quality Engineering Europe. I'm based here in Zurich, and I'm just the co-pilot today. The real pilot is Dominik, and he's been working for us for about 2 years. Now, mostly in the agile test automation context, and most of what you see here today is actually coming based on his experience. And with that, I'm handing over to Dominik.
Thanks, Michael. So I'd like to welcome you as well. And if you look at this triangle, a lot of projects I have worked on, and I guess also a lot of projects in the industry are looking like this. So you have some unit tests, some more end-to-end tests, but the main feedback about the product is given by manual testing. And especially if you would like to release often, you really would like to have early feedback, and then this is not a stable setup. And so you really would like to flip the testing triangle, and after flipping you have a solid foundation with unit tests, on top the integration test, and as the tip of the iceberg, the end-to-end test. And end-to-end test means for us, it's just the you're opening the browser and going through the flow, through the business flow, for example, selling an item. And if you're thinking about if you're having an existing team or an existing product and you would like to flip the triangle, does it make sense to go down the pyramid from the top, or what's the best idea to do the transition? And we learned it makes sense to go down the pyramid from the top, so to write the end-to-end test first, because if you write the end-to-end test first, you don't have to change the software itself. You write this extra layer of software, and if you later on write the integration test, you can use this as a safety net. Because if you have ever seen software that has been written without having unit testing in mind, you know, if you write integration tests or unit tests, in the end the software needs to be refactored. And for this, it's a good idea to have a safety net to make sure no new bugs are added. And the other thing that's important, if you try, or if you have the possibility to push down the tests, the pyramid, please do it, because there the tests are cheaper and faster to execute, so in the end you get earlier feedback. And with this, I'm coming to the next lesson. So I was asked to do a code review of a project that had about 500 test cases that were running on 12 European sites. And in the end, so I'm a technical guy, but it took very long until I understood what is tested and why it's tested. And so there was a talk here at the Swiss Testing Day some years ago about test aspects, and we said, okay, let's try this out. So test aspects describe what is tested rather than the how. So in the end, it's just a single sentence, like buy an item and pay it with PayPal. And with this, also the non-technical folks can understand what's automated. And also the advantage of this approach is that the product owners, for example, who are mostly non-technical folks, they can review what's automated and they can also give feedback. And that's something that we do, and where we have seen this really make sense, and we got really good feedback. The other thing is, if we have classical manual test cases, we write them in the normal way with all the details. And for example, in the agile projects, we use the tool Rally to manage the backlog and so on. And there you can also create test plans. So we have a test plan with all the manual test cases. We have a test plan with all the test aspects. And this enables, in the end, us to do a comparison between what's automated, what's done manually. And so we can also find duplicates. And this helped for us. And with this, I'm coming to the next lesson. And it's about if you're talking with tool vendors, they are always trying to tell you this is the perfect tool for you, and if you have bought this tool, everything is fine and all your problems are solved. But in the end, the tool is just executing the test that the testers have scripted, and the tool does not tell your tester how to test. And even if you use open source projects like Selenium, in the end, you need to think about a test strategy. And how we are doing this is we have a clear test process, which means we are writing the automated test cases first with test aspects, and then later on we design how the code is structured, and we call this the BIS domain layer. And the BIS domain layer contains page objects, which are abstractions over interactions of a web page. So for example, if you have a shopping cart, you have, for example, the business functionality to remove items, to update the quantity. So this would be some methods in this page object. And then there are probably business flows, and these business flows are mapped to flow objects. And with this, this is working very well for us. And in the end, it's very important to have a strategy and not just use a tool or an open source framework. And with this, I would like to hand it over to Michael.
So we're splitting this up a little bit to catch some air. Good. So the next lesson, I'm not sure if you can see that, but probably most of you know this picture, right? And what it comes down to is write the right tests. Today, especially with test automation, you can write 1 million tests, or you can generate 1 million tests, right? So having a lot of tests today is maybe nice. You can impress a few things. I think James also talked about that it's stupid to count test cases. Yes, I totally agree. You need to find the right tests, and those are, and if you have as few as possible of the right tests, that's exactly what you probably want. So for us, how does that translate into what we're trying to do? It basically, we would advise to automate your business-critical tests, right? Or, sorry, your business-critical use cases or user stories or requirements, whatever they are called. So in our case, those are the use cases where the $68 billion are transacted every year, right? That's what we focus on. If a help page is not picture perfect, okay, not ideal, but in the end, no big deal, right? So that's basically where we focus our efforts, and we try to have as few test cases as possible. Another aspect is focusing on end-to-end, really on end-to-end, right? Don't get carried away and then all of a sudden trying to validate some UI components on the page. If you're doing end-to-end testing, make sure that that's exactly what you do. And what does that mean? So in our case, as Dominik already said, you fire up a browser, you sign in, you do something, you buy something or you sell something, and then you close the browser again. And yeah, so what you need to take care of is also, sorry.
If you do the end-to-end testing, that it also contains, if, for example, a batch job needs to be executed, then just execute the batch in between the test execution. And the other thing that's very important, talk to your developers and make sure that in the end you have a tool or a tool that's easy to test. Design this testability into it. For example, add IDs. That makes just easier to automate the tests.
Yeah, exactly. So yeah, so really end-to-end, captures, batch jobs that you want to execute, put them into your automation solution, into your automation suite. No point in having only a half-baked end-to-end piece, but no, maybe the captures or the batch job you still need to trigger off manually. Yeah. And then the last thing is design testability into your product. Like, I think most people probably have, who have worked in automation, don't have, or sometimes come across a thing where they don't have IDs on the elements, right? So every time something changes on the page, new IDs get assigned to the elements, and then all of a sudden your entire test scripts blow up, right? So design that right into your product, right from the beginning, yeah? I think otherwise, you just have this huge mess in the end where every time somebody changes something, and if we live in an agile world, things change all the time, right? And then you basically, all you do is maintain and you up-rev your test cases to the very latest version, yeah? So testability. If you want to see how testability shouldn't look, is you just go to the eBay search results page, and you look at, like in one of the inspection tools, you just look at how an eBay checkbox looks like, the HTML code, right? It's absolutely horrific. So they totally over-engineered a very simple checkbox, and it took us, I don't know, how many days to actually be able to click that one checkbox, right? So don't over-engineer things. Good. The next lesson, instant feedback is essential. Who in this room works in an agile environment? Who would like to work in an agile environment? Okay. Good. I think regardless if you call your cycle sprint or if you're still in waterfall, in many cases this is how your development and your test phase looks like, right? You develop a piece of code and then at the end you test it. And your test can be either manual or automation. It totally doesn't matter. What you want is, however, probably something like this, right? Where you develop a piece of code and you immediately have the ability to test it, right? Instant feedback. And this can only really be done by test automation, right? If you do this manually, if you every time a developer checks in a piece of code and you have to ask a tester to test, probably you don't get that instant feedback, right? So also instant feedback means test execution times of as little as you can, right? Which in our case I think is kind of like an hour for about 3,500 end-to-end tests. Yeah? Now you may ask, how do you do that? And how we do it in our case is, Dominik already mentioned it, we use Selenium. And there's a component in Selenium called Selenium Grid. And that allows you to parallelize your tests. And that's exactly how we are able to come down to these 1 hour slots. If we didn't have that, it would take us 5 days to execute the 3,500 end-to-end tests, right? Because we really go all the way through. We really go all the way end-to-end. Yeah? And of course, also, if you get this instant feedback, I mean, why you do this is to find bugs or defects early, right? You don't want to find it out at 2 days before you go out and release. You wanna have it right away. But in order to do that, you obviously need a proper test infrastructure and proper test tools. And in our case, as I said, Selenium Grid. For those people who didn't know, actually Selenium Grid was developed by engineers at eBay, and then we open sourced it. So today it's available for everybody to download. All right. Lesson number 6. Automation is software development. And it really depends how your automation looks like in your companies. I know there's a lot of drag and drop kind of tools out there for test automation. We went a different route. We actually write code for our tests. So, as I mentioned, we use Selenium. eBay is a Java shop, so we also write our tests in Java, right? So the people who write the automation also need to know how to write Java. They need to be basically software engineers, right, who have a strong appetite or willingness to test. And that's basically our key learning as well, that you can't just put anybody on there. If you don't have technical skills, then maybe test automation, at least the way we do it, is maybe not the right thing. You obviously have to have an automation mindset, yeah, as an engineer. So maybe writing some business logic is a different story or a different approach than if you actually write test automation code. And you need a very good understanding of your architecture and your application that you test. We don't have separate teams, so we don't have a manual testing team and a automation team. We don't have that. So our manual testers actually write the automation as well, right? Because they have the domain knowledge. Otherwise, what you end up with is the manual testers, they create the 1,000 test cases and then they throw it over the wall to the automation guys, and then they implement that one by one, right? But if you have the overall domain knowledge, like what we have, we take care of 12 sites in Europe. So those 12 sites, sometimes you are similar and sometimes they are different, right? But you have to have that overall knowledge how to basically design your test automation software so that you have modularization, you have maintainability in the end. Yeah. Good, and then of course you have engineering practices like, just basically everything that you would expect from a good software development project. My advice is just also apply that in your test automation, right? Same standards or even better, right? Our aim is to be actually better than our development peers because then we can impress them and they respect us, right? Finally. All right. I think that's that, and now it's back over to Dominik.
Thanks. So the next topic I would like to talk about is maintainability is king, and I brought with me a small cartoon. And there's also another one. So in the end, I was working together with a team. So they started fresh on test automation. So I have trained them, and then afterwards, the concept of this exercise was that after the training, I worked with them as a coach together for a certain time period. And I have done often code reviews and so on. And in the beginning, what I've seen, they have really written good code. The code was well structured, easy to understand. They followed the layers, and everything was fine. And then what happened was that after several iterations, they got more and more pressure from the product team, and then they developed the software. And then after a certain time, they asked me if I could do a code review again. And so in the beginning, I looked at the continuous integration server where you can trigger off all the tests, and so everything looked fine. So the tests were executable, the history was looking good. And then we are using another tool. It's called Sonar. I don't know if you know it. It's an open source tool where you can deep dive the code and also different programming languages. And it's really a brilliant tool where you really get insights about your code. And so the first hotspots were popping up. So for example, the code duplication rate was going up, the API documentation rate was going down. And so I started doing a code review. And what I've seen was that in the end, the code was really hard to maintain. So we had this technical debt, and there was the question about how we can handle this. And then we came up with the idea to, we have read about this lean software development, and there you have some basic principles. For example, eliminate waste, build quality in, defer commitment, and create knowledge. And what does this mean is, for example, eliminate waste. You can adapt this to different things on the product. So for example, don't implement the features that your customers don't need, or so how we do this is, for example, that we say, okay, if we have any tests that are useless and not used anymore, we just delete them. Or if you have any test methods that are not used, we delete them just to have a clean state. And the other thing is also, it doesn't make sense to write, for example, 100 pages of Word documents if no one is reading it. Just document what's essential. And things that can help you with this is, for example, the definition of done, and also doing code reviews. So we're doing code reviews very often, and this really helps to share knowledge and also make sure that you have a common coding conventions that are used by the whole team. And that's also something with respect to build quality in. Coding standards, static code analysis, or programming practices like defensive programming. The other thing that's also very important is respect people and the long leash. So it's more like a management topic, but also it's important to give your teams room to try things out. And as Michael already mentioned, the Selenium grid was written in our team. So because one engineer, so in the past we were using Selenium 1, so Selenium RC, and there was a grid there, but then on the horizon we already have seen Selenium 2, Akka WebDriver, and we have seen, okay, there's no grid available. And then the engineer started looking at this, and then he has written the grid, and now afterwards it was open sourced, and I think it's a very good example. Michael, do you would like to add something to this?
Yeah, just one thing. So when we started, or so François Renaud, he's in my team, and he's the guy who wrote Selenium Grid. When he said, I'd like to do this, or I didn't know if there was a positive ROI on it, right? So just wanted to say that. So not everything that we do, or that you allow your engineers to do, needs to have a positive ROI or anything. I had no idea. We said, okay, we need this. Why don't we play around with it, and off you go, right? And then he came basically back, I don't know, probably 2 or 3 months later, and he had it, right? And today, I believe Selenium Grid has about 2,000 downloads every single day, yeah? So hugely successful, not just for us, but also in the entire testing world, yeah? I was actually in Australia a few months back, and the guy who wrote WebDriver or Selenium, so Simon Stewart, he's the inventor of WebDriver, which is now Selenium 2. He was there, and he was actually talking about how Google today uses Selenium Grid, right? So very nice story, I think, if you give your team that long leash, that's how we call it. So don't worry, we don't wear leashes at work. But that's how we call it. We just give people room to play around, to do things, and sometimes they work and sometimes they don't. But in this case, they certainly worked out very nicely.
So, and the next lesson that we have learned is about the collaboration between the developers and the testers. So if you look, for example, our agile teams, they are designed in the following way. We have testers and developers in the same team, and the testers have mainly, they are manual testers, but they have also programming skills. And so what Michael already mentioned is that the business critical software in Europe is written in Java. So we also decided to write the test cases in Java. And that helps because in the end, if the testers are out, also the developers can write the automated test cases. And also at some point, maybe the testers can also fix a bug. And the other thing is that we can have this cross-functional team. And at some point we had in one team the issue that in between the test execution a batch needed to be executed. And the thing was that the batch was not designed to run in parallel. So, because we run all our tests in parallel, we had an issue. And so the QE engineer was sitting down, and in the end he developed a shell script based on, he implemented a shell script with a lock mechanism. And in the end, so everything was working, and then he showed this to the developers, and they really were impressed. And also what we have seen later on in discussions that, yeah, there was really a high regard, a high respect how they were talking to each other. And so this helped really to get things done. And so this collaboration is very important. And with this, I'm coming to another important lesson. So you would like to have, so especially in Agile, fast feedback is important. And to do this, one thing that's important to look at the component, the scalable testing environment. And for this, for example, it's important to have the number of application servers and databases you need to have. For example, if manual testing and the execution of the test automation suite is running in parallel, maybe it's a good idea to duplicate the testing environment. And it's easier if you do this with virtualization. And to make virtualization easier, maybe tools like Vagrant and Puppet can help you. And the other thing is that we have in our environment is the Selenium Grid. So this is running in a virtualized environment on a VMware ASX server. So that means that with this, we can run our tests on different operating systems and also different browsers. And so eBay has also a Win32 application. It's called TurboLister. If you would like to list a lot of items, you can use this. And so we have also written a framework how to test this Win32 application. It can be plugged into the Selenium Grid. It's called Twin. You find it on Google Code. And with this, we are even able to run the automated test in a virtualized environment. And because we are running those tests for 1,200 for the 12 sites, we have to support the different languages. So we have different virtual images for different countries. So a test starts then by installing the corresponding version on the fresh image. Then we execute a test, and the big advantage is that later on we can just revert it back to the fresh state, and then we have always the same state to start. So there also virtualization helped us. And another component I would like to talk about is are tools that help you to create data, for example. And so I brought with me a screenshot of the DCT tool. It's a data creation tool. With this, you can just enter a username, an email address, and after selecting the corresponding site and the type of seller, the eBay user is just created. And the good thing about it is that it takes just a second. And you can use these kind of tools for manual testing and also for test automation. And so things get easier. And the thing is that the most important thing is if you have such a tool, just make sure that this is only available in testing and not in production. And now I'm coming to the mainly the most important lesson, so that manual testing is very important. And test automation is, in our case, not about eliminating manual testing. And also we have very often discussions about if it makes sense to have this 100% test coverage. And we very clearly say, so it doesn't make sense to have this 100% test coverage because there are always areas that are very hard to maintain and where it's just easier to automate it, to run manual tests. And for us, the automation is just a safety net who is doing the repetitive work and is giving the manual tester the freedom and the bandwidth to look at the interesting parts. And the other thing is also that if you look at test automation, the good thing about test automation is always running in the same way. So you have this reproducible test result or a test execution, and that's something that we would like to have. But on the other side, it's also important to go off the beaten path. And that's something that we do with exploratory testing, and this combination works very well for us. And a practical example, if you look, for example, at the eBay site, there are 39 sites worldwide, and the bulk of the tests are done, so of the eBay user registration are done via automation. But we know the important parts, we know the critical parts, and these parts are tested manually. And so this combination is working very well for us. And manual testing is very important. And with this, I would like to hand it over to Michael.
Okay. Yeah, so we never know where to put this slide. So should it be the first lesson learned or the last lesson learned? I think for us, it's the most important lesson learned, right? All the other stuff is important as well, but that manual testing is absolutely crucial to finding your bugs. That's basically our key takeaway. And you hear a lot about super highly automated environments, that's all great, but you always will need manual testing and good manual testers, right? I think that's also so. Just from my perspective, people who today only work in a manual environment, perfectly fine. Don't get too nervous that your job's going to get automated away, right? Maybe the space is going to be a bit smaller, right? But actually, if you're a very good manual tester, your automation actually takes or creates all this additional bandwidth for you to really go wild and crazy and test in a manual way, right? That's basically the. Again, I think that's the that's the timer. Good. All right. So quick conclusion. I think so. We saw flip the testing triangle. We saw tool is not a strategy. So don't just buy a tool and believe your tool vendor or the manual that it all of a sudden will solve every single problem that you had. Everyone should know what's automated, yes, because otherwise, if not everybody does, then it's kind of difficult because, if the manual testers should also know what is automated, because if they don't, then they will probably also do the stuff that's already automated. Write the right tests, instant feedback, shorten your test execution times, super important. Automation, software development in itself. Maintainability is king. and speak the same language as your developers, invest into test infrastructure, and manual testing is still important. And maybe just a little story. This just came to my mind. I was in Romania last week, and I was talking at the kickoff conference for the Romanian testing community. And I was doing this presentation there, and people really liked it. And then in the evening, we were sitting together with a bunch of people, and we're talking about what is it like to work at eBay for a Silicon Valley company. And I said, it's really fun. I've been there for 8 years. I love working there. But what we, and then I saw these guys, they work a lot, right? They work like 14, 16 hour days there. And, then I said, hey, whatever you do, I hope you took away a little bit of what I said here, but whatever you do in your daily work, always look at it from, do you work to live, or do you live to work, right? So they're two very, very different angles. And I think, at eBay, I hope that everybody in my team at least agrees that we work to live. So we like our work, but we also, in the end, we do it to live and to have fun. And that was a nice thing. A few days later, one of the ladies there who I talked to, she said, that was actually lesson number 11 that you should have put on your slides. And so I just wanted to share that little story, that I think whatever we do in general, we can focus on technical stuff, on testing, on development, but in the end, don't work yourself to death. So from our perspective, work to live, have fun testing, but don't forget the living part. And with that, I think, yes, we're done. And I believe we do have a few minutes for questions.
Yes, thank you very much, Michael and Dominik. So feel free if you have some questions. We have enough time for it. Yeah? The importance of unit tests.
Yeah. Dominik, you want to take that?
Yeah, the unit tests are very important because with them you get really, really early feedback. So if you have the testing triangle, you have seen that if the triangle is flipped, then the solid foundation is unit tests. And if the developers just are writing a piece of code, then it's just easier to write a test immediately or write the test before. And later on, if you've changed something, you just run the test and you get this immediate feedback. Because if you're looking at the end-to-end test, they're doing a good job, but in the end, you need to deploy the software, the database needs to be initialized and all this kind of stuff, and then you can test something, and it takes very long until you get the feedback. But if you have unit tests, you get the feedback very fast, and that's the most important thing.
So the reason why we talked about end-to-end is because probably if you start a project from scratch, focus on unit testing, because end-to-end is the most expensive in terms of time, execution, infrastructure, and all that, right? So if you have the ability to start from scratch, or definitely do unit testing. But if you don't, if you already walk into a kind of a mess, right? Then we found that this was a good approach to create yourself a safety net, right? And then slowly start and refactor your code so that it is actually unit testable. Because our experience is also that generally code that doesn't have unit tests is also extremely hard to unit test, right? Because it wasn't written with unit testing in mind.
Yeah, you have these very, very long methods.
Yeah.
And it's really hard to test specific pieces of this, and so, yeah.
Any other questions? Yeah.
Yes.
So, if I understand, how organized our code review?
Yes. Well, you know what I meant.
Yeah. Okay. So from the size perspective, so the teams, it depends. So it's going from 5 developers and 1 tester to where the tester also can write test automation, or it's going to 8 or 9 developers and 1 manual tester and 1 test automation engineer. And so the other thing is that we, from a end-to-end test automation perspective, reviewing the code. So what we have done is that we, as the quality engineering team, we have reviewed the code of the test automation engineer, and but inside the developers, there we have a tech lead, and there the tech lead is doing the code review. Yes, so the test automation code is reviewed and the production code is reviewed. And this, the important thing is also to share knowledge, and also you can help to write better code. And so we made really good experiences with this.
Still time for other questions? Yes?
What about the timing on the requirements and implementation? Do you all have requirements time before implementation?
I didn't get the question completely.
If the requirements come in time to implement the test automation, correct?
And also the product.
Sorry,
the timing of the requirements, which might be approved before implementation, is that working fine on your side?
Yeah, so
you need to have test results compared with expected results, meaning you have requirements which have to be fulfilled by your code.
So if we look at the agile projects, there it is designed in, because we say in the beginning we have to, before a sprint is starting, we have the planning meeting, and there everything needs to be there. And because also the whole team is committing to the sprint backlog, in the end every information needs to be there. And so then all the requirements and all the details are there, and then the test automation can be written, or the test can be done. But on the international projects, Michael, you would like to say something?
Yeah, so we have different ways of, so we do waterfall, we do agile, and everything in between as well, and mostly everything in between. But basically, so for the more waterfall-ish projects, what we do is we test the projects manually, then they go live, and then we automate them, right? That's how we do it. I'm not saying that that's the right way, but that works for us, right? Because otherwise, I mean, of course, ideally you have your automation already in there before the code goes live. Sometimes we can, right? But I would say 80% of the cases we actually do it right after the code goes live into production. Yeah. So that's.
What's helping us is that we then, if we do the feature test manually, then the thing is that we know the product, we create the domain knowledge, and then if we write the test automation, we know what needs to be automated, because we then have the domain knowledge. And also the thing is, do we find bugs with test automation? The most of the bugs we find with test automation is while we write the test, not while executing. We're making just sure that the old stuff is just working, but the most of the bugs are found during writing the tests.
So don't measure the success of your automation based on how many bugs you find in regression. That's completely, not saying anything, right? Because exactly, we find most of the bugs in the process of writing the automation.
So I think, last question, maybe quickly. This time I'm coming to you.
Regarding your manual test part, what kind of tests do you still execute manually? Do you only do exploratory tests manually, or also do you have test cases which you need to do manually because you can't automate them?
Yeah, so there are certain test cases. For example, in the one product, we send out weekly emails, and there different third-party systems are involved. So this would be very hard to automate because there's not really a good test system there and so on, and it takes very long until this email will be sent. So these are parts that we test manually. So there are still parts that we normally test and that are, and especially those parts that are hard to automate.
And yeah, and we also, so again, we have a little bit of everything. So we have test cases that we, trace back and forth to requirements and user stories and all that, but we also do a lot of exploratory type testing. And again, that's where we find most of the bugs, right? So you can have 10,000 test cases tracing back to some requirements. Most of the bugs are actually found in an exploratory way. Yeah.
Okay, thank you very much, and a little thank you from conference board.
Thank you very much.
Thank you very much.
Thanks a lot.